Hello and welcome to the 2021 capstone event for the Project Jupyter Internship at California Polytechnic State University in San Luis Obispo. That's a really long name, and so we call it Cal Poly for short. I'm thrilled to be presenting today. I'm thrilled to be introducing today the phenomenal work undertaken by this summer's cohort. This summer, more than ever, our internship was made possible by a wonderful group of community mentors and collaborators, but I did want to take a moment here at the beginning to introduce the Cal Poly team. We have Brian Granger, founder of the program, Christine Moon, operations coordinator for our team, and myself, Ana Rubalcaba, director of the program. I also, next slide, please. I also want to take a moment to acknowledge the funders. Without them, this program would not be possible. This list includes past grants and current funding for our group. We have the Leona M. and Harry B. Helmsley Charitable Trust, the Alfred P. Sloan Foundation, Schmidt Futures, and also the Gordon and Betty Moore Foundation. So what are we going to talk about today? On the agenda is first an introduction to the program provided by Brian Granger, who I'll introduce here in just a moment. And then we'll have two presentations, one presentation from the Jupyter Bifrost team. And so I'll now turn the presentation over to Brian Granger, who is co-founder of Project Jupyter, professor at Cal Poly, principal technical program manager at Amazon Web Services, and founder of this internship program.
Thank you, Anna. It's great to be here today and see the third intern project presentation for this summer. And I wanted to take a few minutes to introduce the internship. We've been running this internship. The first iteration was all the way back in 2005 when I was at Santa Clara University. And the goal here is to have students solve real world problems that matter to Jupyter users, and includes both design, UX design and software engineering to build something and ship it in one summer. So next slide. And for the last, I guess, since 2010, we've been running the program from Cal Poly, as Anna mentioned. This program is full-time for 11 weeks in the summer, part-time during the academic year. One dimension that makes this program unique is that we hire students in teams of 3, where each team has 2 software engineers and 1 UX designer on the team. And we really emphasize and follow a human-centered design process for the work that the teams are doing. This year, one thing that's new is that we've had broader members of the Jupyter community and adjacent communities mentor the interns. And so at this point, we'd like to acknowledge the interns for this team. Next slide. So for this Bifrost extension, we've had Arvind Satyanarayan from MIT, Piyush Jain from AWS, as well as myself. And then we've also had 3 other people in the Jupyter community mentor students available to answer questions. Zach Saylor, who's a software engineer at Apple, Steven Silvester, also a software engineer at Apple, and then Kevin Jahns, who's the creator of YJS, a fantastic CRDT framework that we're using in JupyterLab now, who's been working with QuantStack and the JupyterLab team on real-time collaboration in Jupyter. Next slide. All right, with that said, let's go ahead and turn the presentation over to the Bifrost team to learn about their summer project.
I do have a few logistical reminders before the team gets started, but go ahead and get ready to start now. I did want to share that we have a couple ways to communicate with us. One of them is the chat channel for general comments and or any issues you might be having with the webinar. The other is the Q&A section, and you can find that at the bottom of the Zoom window where you can enter questions. You don't have to wait until the end of the presentation to enter questions. You can go ahead and do those throughout, but the students will have a little bit of time at the very end for questions. So feel free to use both of those areas to communicate with us. So with that, I'll let the students introduce themselves and their work.
All right, thank you so much, Anna. Hi, everybody. Thank you so much for coming. Today, we'd like to talk about Jupyter Bifrost. It's an interactive data visualization extension for JupyterLab. We'd also like to thank our mentors, Piyush and Arvind, for all of their help creating this. Their help was really essential. I'm Angela, the designer on this project. I'm a fourth-year graphic design student at Cal Poly.
Hi, I'm Jay. I'm one of the developers in this team. I'm a master's Cal Poly student in computer science.
And I'm John. I'm the other developer, and I'm a master's student at Cal Poly studying computer science.
Here's what we'll be covering today. We'll talk about why Bifrost is so important, the process of developing it, a quick demo, and then future implementation for Bifrost.
So why Bifrost? Let's start with the pros and cons of the current visualization tools used in Jupyter environment and discuss what makes Bifrost so powerful. Visualization tools are essential to summarize and understand the data, and both the existing static and interactive tools serve as a great standard. Some people utilize the static visualization tools like Matplotlib or Seaborn to understand the distribution of data, while others rely on interactive visualization tools like Altair, Bokeh, or Folium to interactively play with the data and quickly hone in on their points of interest. However, even though they serve as a great standard to describe the data, they have a few limitations. First, they require iterative coding. In other words, we need to write a Python code and run a cell every time creating a new graph, or even making a simple change in encoding a mark. Second, to create a graph, it is inevitable to explore data first, since you need to specify columns for each axis and mark type. You might think this could not be a big of a deal with the small data set, but with the large data set, it could slow down the process of data exploration and quickly extracting key insights from the data. Third, they support only one-way data flow from Python code to visualization. It's easy to bring data into visualization, but difficult to reproduce the changes in graph back into the Python code. Lastly, since the visualization is now well integrated into Jupyter environment, you can easily find the notebook getting cluttered, like the snapshot on the right side, and find yourself getting confused with the order of cell operations. As a solution, we introduced the powerful interactive visualization extension, Jupyter Bifrost. As the name indicates, it allows for exploration between code and visualization, much like the rainbow bridge between worlds in Norse mythology. Bifrost has a few key features for faster data exploration. Previously, a little bit of understanding of data was required to create a graph, because you need to specify the columns and the most applicable mark type. But with the recommendation system that Bifrost provides, they can get a head start and easily create a chart of their interest. They can quickly go from no chart to full chart while getting immersed into the data without any pre-data exploration. Once the chart is created, Bifrost easy editing capabilities with a simple user interface to add encodings, change mark, or more, really circumvent the need of writing a Python code to replot the charts and speed up the process of data exploration. Also, in the History tab, it saves all the user interactions with Bifrost, so users can easily go back to the previous change and make a further edit. Moreover, it is well integrated into Jupyter environment as a Jupyter widget, so users don't have to change their workflows to use Bifrost. In addition to all of these wonderful features for faster data exploration, Bifrost also supports bidirectional data integration of user interface and the code. It provides smooth bidirectional integration, allowing users to export their final changes as a pandas data queries or save them as a pandas data frame. To sum up, with all of these wonderful features that BiFrost provides, it really helps users to focus on extracting key insights from the data without getting distracted from writing a code. With that, I'll pass on to Angela to discuss about the process of the development throughout the summer.
Great, thanks, Jay. We started with research first into the visualization tools that are already out there. Specifically, we took inspiration from B2 and Voyager, Data Voyager. From B2, we took inspiration from their history log that kept track of interactions with the user interface. And from Data Voyager, we took inspiration from their chart recommendation system and their unique system for defining encodings. We then moved on to user research, creating personas and empathy maps to get a good idea of our archetypal user and their main pain points and goals. We then created user and task flows to make sure our extension was based around the idea of maximizing those goals and minimizing those pain points. Next, we moved on to experimentation. We started with Figma mockups, which were hypothetical versions of Bifrost that helped us to work out data user flows and experiment with UI design. These were really easy to iterate upon as well. Based on this, we created a working prototype, which we used for user testing and became the final version of Bifrost. Let's go over the evolution of some of the screens for Bifrost. We realized immediately that the history screen would be really important because it keeps track of user interactions to help with both iteration and reproducibility. It started with a really simple sketch. Our first conception of the history panel was linear, where users could go back and view previous interactions with the user interface, and any new edits would be added to the top of that list. We then experimented with a branching tree history system, where when users went back in time, viewed a previous state, and made new edits, those edits would be saved alongside their previous version of edits. Originally, this was conceived of as a very literal branching tree. It was later simplified to a file system like Metaphor, where that new branch of edits was nested underneath of the state that it was based on. Finally, we simplified all the way back to that linear model, both for ease of implementation and usability from the user side. In this version, users can go back and look at previous interactions with Bifrost, but the interface only preserves their most recent set of edits and not their previous one. Next, we moved on to user tests. Our first ones were structured and task-based, focused on testing UX mechanics and the overall intuitiveness of the interface. Next, we moved on to open-ended user tests, giving users a data set and asking them to pull insights out of it. This helped us get an idea of the natural data exploration flow of Bifrost. All right, and I'll go ahead and pass it off to John for a demo.
Thanks, Angela. Today, I'm going to be taking us through a data exploration workflow using Jupyter Bifrost. If you've used Altair in the past, this is going to look very familiar. You import the chart object from Jupyter Bifrost. You load your data into a pandas data frame, the same as you always would. And then you pass the data frame to the chart object and plot the chart. Today, we're going to be looking at a California fires data set from 2013 to 2019. It looks at the destruction caused by the fires, where they occurred, and the resources allotted to each one. And we want to see if there is any connection between the resources allotted and the destruction caused. Immediately when you launch the chart, we get presented with this column screen. And this is a really nice way to introduce yourself to a data set. I could know nothing about the features in this data set, and I'm presented with all of them in a nice list. It's also very searchable. To start out, I want to see this from a bird's eye view. So I'm going to look at the overall acres burned by the year of the fire. And just like that, Bifrost produces several charts that could possibly be of interest. Not only does it produce these charts in a nice scrollable formation, but it also assigns different fields to each axis and puts aggregations on the fields like mean. this chart actually seems like a good place to start, because it's a bar chart with the mean of acres burned by active year. And now we can go on and edit the chart. Looks like 2013 through 2017 had pretty expected fire years in terms of acreage burned. But 2018 looks to be an outlier. So let's zoom in on that and go up here and brush over 2018. Now I want to subdivide 2018 by the fire names. All right, this looks a lot better. So it looks like the ranch fire was the biggest fire in terms of acreage, followed by the car fire. And then we also have the campfire here. To me, this is a bit surprising because I remember the campfire as one of the most prominent fires of the year. Seems like acreage burned might not be the field we're actually looking for here. There's got to be other metrics that bring out that prominence. Let's look at structures destroyed. Okay, yeah, I remember the campfire had a lot of destruction in terms of overall property. You can also look at fatalities. Once again, the campfire is the majority of the fatalities that year. As you can see, this is a huge problem for the state. Let's see how resources are allocated relative to the fires. To start, I'm going to look at the fire crews involved on the x-axis versus the acreage burned. And this would probably look better as a point chart. Okay, now this makes sense. When more crews are involved overall, it seems like less acres are burned. And we could hover over each of these points and get more information about the specific fire. But this isn't necessarily the complete story. Crews involved are definitely the core of any fire team, but there's also tankers and dozers and engines that actually either move around Earth to create fire roads or supply water. So it'd be nice to have an overall resources category here. To do this, let's look at our fields, see if there's a resources field. Well, it doesn't seem like there is. So let's jump back out of Bifrost into good old Pandas data frames and make one. So here, I'm gonna make a resources field that is just roughly a sum of all of the resources available in terms of engines, crews involved, and dozers. Run this. And before I plot, I could use the Python API to go back to something very specific and skip the onboarding section. I know exactly what I'm looking for. I want to plot the resources by each county to understand how they're divided throughout the state. So I could say in code, the county or the resources to the x-axis and the county to the y-axis. And then this would look great as a bar chart. So I'm going to say mark bar. I call plot on that. I'm presented with the chart that I was looking for. Right now the data is sampled, so let's use the entire data set and see what we could look at here. It appears like San Diego has the largest amount of resources, followed by Riverside and Butte County. But it would be nice to see how these resources actually affected the fires in the area. So I'm going to switch this from resources to acres burned. As you can see, it seems like the areas with a lot of resource have much fewer burned acreage, which would make sense. And then areas with less resources seem to have more. And if you want to easily jump between, you could always use the history tab. But the Lake County seems to be an outlier here. It had a lot of resources, but it also has a lot of acres burned. So let's look into this in more detail. I want to see the fires involved in this section. Whoa, so it looks like the majority came from the ranch fire. Not just that, But the ranch fire seems to be involved in several of these counties, making up the majority of the acres burned. This is something that's super powerful about Bifrost. It gives you the ability to come up with certain, to see correlations that you weren't before. We were looking at counties and fires as like a one-to-one relationship. But the fires themselves don't obey county lines. And so by looking at this graph, we could clearly see that these two counties are dealing with the same fire. And maybe we could approach this data exploration in the future with a more holistic view throughout the state instead of dividing resources by counties. Now, it looks like this ranch fire is really interesting, as well as the campfire in Butte County. And I want to see this, why San Diego has so few acres burned compared to the total number of resources that they're allotted. So I'm actually going to isolate San Diego versus Butte here. And I want to look into it in pandas. In any other program, this would be very difficult. You would have to take what you've done in the program, remember everything that you've done in the graphical user interface here in the chart, and then recreate it in pandas. But the amazing thing about Bifrost is I could actually take all my edits and put it back into pandas and just keep going in the code. So to isolate these two counties, all I have to do is go here and select each one individually. So I'll select Butte, and now I'll go down and select San Diego. And then just by filtering there, when we see this complete list of counties, if I run this cell again, the result has already filtered down to just San Diego and Butte. And this is really powerful because I didn't waste any time recreating, backtracking anything. And I have all of my changes in code. Let's jump back to the previous version. I really like this. I think it's a really good graph, and I want to share it with some of my colleagues. Go up here and export it as a PNG. You have an easily shareable PNG on the computer that you can send to anyone. I hope this gave you some insight into how you could use Bifrost in some of your workflows. It's really great for exploring data quickly and jumping from code to visualization and back. And Angela is going to take it away now to talk about the future implementations in Bifrost.
All right, thanks, John. Here are some of the features you might see in Bifrost in the future. With a little bit more user testing, we can implement that file system history so users can save multiple branches of interactions alongside each other. You might also see a simplified and improved user interface to let users focus on exploration of data instead of navigation. Finally, you might see better handling of large data sets and different data types like time series. All right, thank you so much. We have a little bit of time for comments and questions now. It looks like there's a few questions in the Q&A already. Rajesh asks, is Bifrost available, already available for use? I'll go ahead and link to our GitHub repo where you can check out the current version of Bifrost. I can't promise it'll be bug-free, but it is available for download.
Jonathan Frederick asked if Bifrost is scalable, if it works with large data queries. So this is something we started addressing in the final weeks of the summer. We found that with very large data sets with like tens of thousands of rows, we had performance problems. In terms of very, very large data sets where it hooks to an entire database, if it isn't able to be stored in memory, we can't necessarily work with it within our current bounds, but we do have the ability to sample these large data sets and provide a subset of useful data that is representative of the large data set. And that's the approach we took. So there is a sampling feature within Bifrost that allows you to extract insights without necessarily looking at the entire data set.
John, can you talk a little bit about how how that sampling kicks in and sort of at what point do you start to auto sample?
So for any screen where there are many charts, for example, the chart chooser screen, where you have those initial columns and you have several charts, we sample more aggressively in those screens because we have much more data represented, much more computation goes into each of the recommendations. When you switch screen, we upsample, and there's actually a sample slider on, I'll share my screen so we can see. There's a sampling slider on this chart screen. And so you could actually control how much of the data set you're sampling. You could see the number of points that you're sampling right here. And this allows you to easily sample your data set without necessarily having to go through the work of doing it manually in pandas. And whenever you jump back to a screen that requires a lot of data, or requires a lot of computation, like all of these graphs, it immediately downsamples you and returns to that upsampled threshold that you specified on the previous screen when you go back to it.
Right, it doesn't look like there are any more questions. So just want to say a big congratulations to the entire team. So great work, everyone. And also to the mentors. Thank you to Piyush and Arvind. This is an excellent presentation. It's really fun for me to watch the culmination of your summer's work. And I also want to provide in the chat link to the Jupyter Cal Poly org on GitHub. You can see the entire summer's repos in there. One more resource I want to share, and this is a general project Jupyter resource, and that's our discourse channel. That is an important point of connection. I don't feel like everyone's aware of it, so I'm taking just a moment to acknowledge it and share it with you all. So I hope you have a wonderful rest of your day. Yes, Brian, do you want
to? Look like Damian has his hand raised.
Yeah, I think that might have been, that was near the beginning. And we did reach out to see if he had a question and didn't hear back. So I think it might have just been a misfire.
Okay.
Yeah. All right, everyone, have a wonderful rest of your day. Take care.